Space travel seems glamorous, with astronauts floating and smiling for cameras. The images we see often paint a picture of adventure and excitement, capturing the imagination of millions. These brave men and women appear to be living out a dream, exploring the final frontier. But space is actively trying to harm us every second. Beyond the serene visuals lies a realm of constant danger. The vacuum of space is a hostile environment where every moment is a battle for survival. More than 20 people have died during space missions or training, a sobering reminder of the risks. These tragedies serve as a stark reminder that space exploration is fraught with peril. Each mission carries the weight of potential disaster, and the loss of these pioneers is a testament to the unforgiving nature of space. The universe is vast, cold, and indifferent to our survival. It stretches out in all directions, an endless expanse of emptiness and danger. The cold vacuum of space offers no comfort, no shelter, and no mercy. We are fragile explorers venturing into an ocean of dangers. Every spacewalk, every mission outside the protective shell of a spacecraft is a dance with death. The thin line between life and the void is maintained by technology and human ingenuity. The vacuum of space is instant death. No air, no pressure. In the absence of an atmosphere, the human body cannot survive. The lack of pressure would cause bodily fluids to boil, and the absence of oxygen would lead to rapid asphyxiation. Micrometeoroids, tiny pieces of rock or metal, zip through space at thousands of miles per hour. These minuscule projectiles travel at such high velocities that they can cause catastrophic damage upon impact. Even a small one can pierce a spacecraft, damaging vital equipment. The integrity of a spacecraft's hull is paramount, and a breach can lead to a loss of pressure, endangering the lives of those on board. Spacecraft need complex systems to maintain a livable temperature. The extreme temperatures of space, ranging from the searing heat of direct sunlight to the freezing cold of shadow, require sophisticated thermal control systems to ensure the safety and comfort of astronauts. If these systems fail, the consequences are swift and unforgiving. A malfunction can lead to rapid temperature changes, making the environment inside the spacecraft uninhabitable. Launch is violent, with massive explosions propelling rockets. The sheer force required to break free from Earth's gravity is immense, and the process is fraught with danger. Incredible forces press on astronauts. It's a controlled catastrophe. The intense G-forces experienced during launch can be overwhelming, pushing the human body to its limits. If anything goes slightly wrong, disaster strikes. The margin for error is razor thin, and even a minor malfunction can lead to catastrophic failure. The journey itself is a gauntlet before facing space. Every moment spent traveling through the void is a test of endurance and resilience, with countless challenges to overcome. Space demands our utmost respect and constant vigilance. The pursuit of exploration requires unwavering dedication, meticulous planning, and an unyielding commitment to safety. Only through such diligence can we hope to navigate the myriad hazards of the universe. Our bodies evolved for Earth, a planet with a specific set of conditions that we are perfectly adapted to. We are finely tuned for its gravity and atmosphere, which have shaped our biology over millions of years. In space, our bodies start to change, reacting in strange and often unexpected ways. The absence of gravity, or microgravity, alters how our systems function. Space travel is a profound shock to our biological systems. The human body is not designed to live in space, and the effects can be quite dramatic. Imagine your sense of balance. On Earth, it's something we take for granted. In space, that anchor is gone. Astronauts often feel disoriented, experiencing space sickness. This disorientation can be severe, leading to nausea and vomiting. Nausea and vomiting are common, much like severe motion sickness, but in a more extreme and persistent form. Fluids in your body shift upwards due to the lack of gravity, causing a puffy face and stuffy nose. This fluid shift can increase pressure inside your skull, which in turn affects your vision, sometimes causing long-term changes. The increased pressure can lead to headaches and vision problems, making it difficult to perform tasks. Our immune system can weaken in space, making astronauts more prone to illness. The stress of space travel can also slow down the healing process for wounds. Wounds might heal slower, The body is under constant stress, trying to adapt to an environment it was never meant to endure. The body is under constant stress, and this stress can manifest in various ways, from muscle atrophy to bone density loss. It tries to adjust to an alien world, feeling the absence of Earth's embrace. The psychological toll can be just as significant as the physical one. Astronauts often feel a deep sense of isolation and homesickness, looking out into the vast emptiness of space, longing for the familiar sights and sounds of Earth. Space is filled with radiation, high-energy waves from the Sun and distant galaxies. These waves travel across the vast expanse of the universe, carrying immense energy that can penetrate almost anything in their path. Earth's atmosphere acts as a protective shield, absorbing and deflecting much of this harmful radiation. However, in the vacuum of space, astronauts are exposed to significantly higher levels of radiation, making their missions inherently risky. This radiation is a silent, pervasive danger, passing through spacecraft and human tissue. It is invisible to the naked eye, yet its effects can be devastating, altering the very DNA within our cells. Galactic cosmic rays and solar particle events are the main types of space radiation. Galactic cosmic rays originate from outside our solar system, while solar particle events are bursts of radiation from the Sun. Both types of radiation can damage our cells, leading to serious health issues such as cancer or cataracts. The damage is cumulative, meaning the longer the exposure, the greater the risk. The risks increase with mission length, especially for long-duration journeys to Mars. As we venture further from Earth, the protective influence of our planet's magnetic field diminishes, leaving astronauts more vulnerable. Shielding helps, but is not perfect. GCRs are hard to stop completely. Engineers are constantly working on developing better materials and technologies to protect astronauts from this invisible threat. However, thick shielding adds weight to spacecraft, requiring more fuel to launch and maneuver. This presents a significant challenge for mission planners who must balance protection with practicality. We try to predict solar flares, but the risk is always there. Advanced monitoring systems and early warning protocols are in place, but the unpredictable nature of space weather means that some level of risk is unavoidable. An invisible storm rages around, a constant reminder of space's hostility. As we push the boundaries of exploration, understanding and mitigating the threat of radiation remains one of our greatest challenges. Weightlessness looks fun, but living without gravity takes a serious toll. Our muscles and bones need resistance to stay strong. In microgravity, that resistance is gone, leading to muscle atrophy. Astronauts must exercise rigorously to slow down the loss. Bones lose density, becoming weaker and more brittle. This bone loss is significant, especially on long missions. Even the heart changes, not working as hard to pump blood. Astronauts can experience orthostatic intolerance upon returning to Earth. Microgravity is a deceptive comfort, slowly weakening the body. Space travel is tough on the mind, with isolation being a huge challenge. Astronauts are far from home, confined with a few others for months or years. This can lead to loneliness, sadness, and depression. The overview effect can trigger anxiety, a sense of detachment from humanity. Communication delays make real connection difficult. Astronauts are psychologically screened and trained, but everyone has a breaking point. The constant pressure of the mission and monotony of routine can build up. Sleep can be disrupted, affecting mood and performance. Maintaining mental well-being is crucial for mission success. Living in confined spaces adds stress. Spacecraft are cramped with limited living and working areas. Astronauts share these spaces for extended periods, leading to irritability and conflicts. Privacy is minimal, and personal habits can become annoying. Team cohesion is essential but can be strained. Constant background noise, artificial lighting, and limited food variety contribute to cabin fever. Astronauts need ways to cope, like hobbies and exercise. NASA studies group dynamics to develop coping strategies. The pursuit of space exploration comes with grave risks. The Space Shuttle Challenger disaster in 1986 shocked the world. 7 astronauts perished due to a faulty O-ring seal. The Space Shuttle Columbia disintegrated in 2003, losing all 7 astronauts. These accidents led to significant changes in safety protocols. They underscore the inherent risks of space travel. Beyond tragedies, there have been close calls. The Apollo 13 mission faced a life-threatening situation. An oxygen tank exploded, and astronauts used the lunar module as a lifeboat. Engineers devised solutions to bring them home safely. The Soyuz MS-10 launch abort in 2018 was another close call. Space debris is a growing problem, a hidden minefield in the dark. The ISS maneuvers to avoid known debris, but the threat is increasing. Space travel is dangerous, with formidable challenges and significant risks. Yet the human spirit is adventurous, driven to explore the cosmos. We must proceed with wisdom, caution, and humility. Understanding the dangers is crucial to prepare and mitigate risks. Future missions require better technology and improved safety measures. We need continued research and a culture prioritizing safety. As citizens of Earth, we can support scientific research and advocate for responsible exploration. The journey to the stars is a human endeavor, belonging to all of us. Let's explore the cosmos wisely, inspired by the possibilities.